What we're going to look at next are secant and cosecant values. So in order to do this, we have to be very familiar with our sine and cosine values. Luckily, a lot of it, what we did in the previous videos, is going to apply directly to what we're doing here today. The difference is that secant and cosecant are going to be defined a little bit differently than sine and cosine. So we do have an identity, or actually two identities right over here, where we've got the secant is equal to 1 over the cosine, and the cosecant is equal to 1 over the sine. So in order to figure these problems out, what we're going to be doing is taking our cosine and our sine values and effectively flipping them. All right, we're going to find the reciprocal of those values. So we're going to start off here with the first quadrant. We know our values already, our cosine values and our sine values, and we're going to try to find the reciprocal of those values. And where we get stuck, we're going to go ahead and figure out that value pretty quickly here. So if I'm looking at 0 degrees, I know that the cosine is equal to 1 and the sine is equal to 1. And I can find the secant and the cosecant values by taking the reciprocal of those. So the secant is going to be 1 over the cosine, so 1 over 1 would give me 1 for the secant. When I do the cosecant, though, I run into a problem, because if I take 1 divided by 0, I now have an undefined value, and so I'm going to call this undefined, UND, abbreviated for undefined. So as I'm writing these ordered pairs, then I've got 1 and then undefined. For pi over 6, that's where we start getting into some issues here. When I take the reciprocal of the square root of 3 over 2, this is what I end up getting, 2 divided by the square root of 3. Now, realistically, that is a correct answer, but we typically don't leave our answers like that. We're going to go through a process called rationalizing the denominator. And the way to do that is multiply top and bottom by the square root of 3, which would give me 2 square root of 3 divided by 3. And then nothing simplifies. The 3 and the 3, I'd like to cancel those out, but I can't, because the square root of 3 is underneath the radical, where this 3 is outside. So when I take the reciprocal of root 3 over 2, it's going to become 2 square root of 3 over 3. And with 1/2, when I take the reciprocal of 1/2, that becomes 2 over 1, which would just be 2. So again, our secant value is 2 root 3 over 3. Our cosecant value is 2, and I can write those out like that. At pi over 4, I run into a nice coincidence that both of my values are exactly the same, the square root of 2 over 2. Again, finding the reciprocal of that gives me 2 divided by the square root of 2, which again is a correct value, but not one that we're going to look for, because we want to rationalize the denominator. So I'm going to multiply the top and bottom by the square root of 2, giving me 2 square root of 2 divided by 2, which equals the square root of 2. So both of those values would be the square root of 2, the secant and the cosecant. So when we look at pi over 3, the nice part is that I forgot to write those values in. Sorry. Square root of 2, square root of 2. There we go. When I look at pi over 3, that's really the same thing as pi over 6, but now we flipped the sine and cosine values. So when we do that, our secant and our cosecant values are going to flip as well. So I know that when I take the reciprocal of 1/2, I'll get 2, and the reciprocal of root 3 over 2 becomes 2 root 3 over 3. So again, my secant is 2, my cosecant of pi over 3 is 2 root 3 over 3. So again, I can write those in. And then at pi over 2, I'm right on that axis right there. Again, I'm going to find the reciprocal of those, but now when I find the reciprocal of my cosine value, it gives me an undefined value. The reciprocal of 1 would give me 1. So if you look at the values at 0 and pi over 2, again, they're kind of flip-flop there. So undefined and 1. So when we get into the other quadrants, our rules of finding the values are exactly the same when we did sines and cosines. We know that in quadrant 2, our cosine value is going to be negative, which means that in quadrant 2, our secant value is also going to be negative. But since our sine is positive, our cosecant value will be positive as well. So if I just picked one of my values, let's say the pi over 6, and I wanted it in quadrant 2, I would change the sign of my x-coordinate, which represents now the secant value, and I would leave the y-coordinate, which represents my cosecant value, exactly the same. I would leave it as 1/2. Oh, I'm sorry, it's 2. I don't know why I wrote 1/2. It's probably thinking of sine instead of cosecant. 2 would be our value. I could do the same thing in quadrant 3. If you look at like quadrant 3, both of our coordinates will be negative. So I could take a value from quadrant 1, let's say the pi over 4s. I know that it's root 2 and root 2, but because we're in quadrant 4 and both the cosine, or the secant in this case, will be negative, as well as the sine or cosecant in this case, that would be my new ordered pair. And in quadrant 4, I could take a value at like 5 pi over 3. So our value at pi over 3 was 2 and 2 root 3 over 3. My cosine or secant will be positive in quadrant 4, but in quadrant 4, my sine and my cosecant will be negative. And so that's going to give me all my values. So again, I'm using what I did before with sines and cosines, but now applying the cosecant or secants and cosecants to that. Again, it's the same thing, just the reciprocal of those values.